Forgot about that. So this series is going to be recorded just for future reference for everybody in EPICS. So let me start again. Thank you guys for joining. Today we're going to be doing the electrical series number 1. Basically we'll be covering the circuit basics and few elements for circuits. My name is Karen Reyes. I am a master's student in the Electrical Engineering Department, and I am pursuing a master's in Controls and Power Electronics. I have been a TA for EPICS for 2 semesters, and I really like the interaction with all the students and to work into the projects. So without further ado, let's get started. So first, we are going to talk about a few concepts that is going to help you to understand the small project that we will be working on today. And we're going to be talking first, what is current? So current is the rate at which electrons flow in a complete electric circuit. So for better understanding, I post this picture on here where we do have, this will simulate the wire, and then those little dots are the electrons flowing in the direction of the arrow. And then the current will be measured in the opposite direction. So the current will be positive when the electrons are going through and negative where the electrons are coming from. So current is also measured in amperes. That's the, and we usually just symbolize with an A. And then our next definition is voltage. And voltage is the pressure from an electrical circuit. It's a power source that pushes charged electrons. So before the current, we were talking that it's just the movement of electrons going from the negative polarity to positive polarity. Voltage, on the other hand, is something that is pushing those electrons. And it depends of how big is the voltage, it will push more electrons or fewer electrons. So for that reason, you can see in the picture over here, this picture has a big truck, just to make you understand better the concept. And this big truck is able to push many electrons. While if we have a small truck, it will just push few electrons. So that's the relationship with voltage. So high voltage moves a large current, while low voltage moves a small current. The unit used for measuring voltage is volts, and we use the V for the symbol. Then, so now we do know what is current, what is voltage, and we're going to be starting to learn a little bit elements. The first element that we want to know is a resistor. And this is a passive element with 2 terminals, and it is an electrical component that it just adds resistance. So it's going to look like this in your right. This is a resistor, and it does have 2 terminals, one branch and the other branch. We can calculate the voltage across the resistor, and it's founded by this formula but we are not going to dig much into this. And however, one important portion about resistors is like resistors add in series. So let's say that you want to have 1,000 ohms, that's the units that resistors are measured, and you do have 2 resistors of 500 each. So in order to make those 1,000 ohms, you will add those resistors in series. So you will add 500 plus 500 is going to make 1,000 ohms. In the other hand, if you connect them in this configuration that is called parallel configuration, instead of adding them, this is the formula that we're going to be using. So let's say I connect 500 ohms here and another 500 ohms. What is going to be the result is 250 ohms. So it actually divides the resistor. So if you have 2 small resistors and you want a bigger one, you can connect them in series, And if you have two big resistors and you want a small value of resistance, then you can add them in parallel. So this is the basic concept about resistors. So why I have talked voltage, current, and resistance. And here is an image for you to understand better. So let's say that this green portion is our wire. And in our wire, we have the electrons flowing. So this electron should go in this way, right? And then, as we said before, voltage is something that is pushing those electrons. So those are helping those electrons to flow, while the resistance that we just talked is making those electrons stop. So resistance is just as the word explains, it's just on a resistive part of the wire, so it makes harder for the electrons to flow. And then the resistors, we do have different values for resistance. And usually in undergrad, we learn to read the values of these resistors, and they are color coded. How do we read and how we can know the value of these resistors is by this color code. And it will have three different bands. Those are the main bands. And depending on the color, it's going to tell you the digits that is going to be. So let's read the first one. So for example, it says that the first band color is red. So we go to the first digit, and red is 2. And then we say that for the second band is green, and we go to the second digit, we find the color green, and it says 5. So far we have 2 red, 5 green, and then we move to the third band. The third band is orange. So we go to the third band digit, and we find the 3. So the value of this first resistance is 2, 5, 3. And it has different ways to read this resistance. We also have the multiplicity, that is going to be our fourth band, and the last one, that is going to be the tolerance. So meaning how above or below the resistance that we are listing, this resistance can have. So this is how we can measure it by color coding. However, this method is just used when we don't have a machine or a multimeter to measure. Actually, it's not very common, but sometimes it's useful to check the colors. It's useful to learn the colors if you don't have like a handle, something in your hands to measure it directly. And then I want to talk also a potentiometer, and a potentiometer is just nothing else than a resistor. However, this can vary the resistance. So it will look like this, and it looks like something that it has a knob, and then you move this knob clockwise or counterclockwise, and that's how you adjust the resistance of this one. The previous resistor that I was talking about, this has a fixed resistance. So you can see with the color code, you have a fixed resistance, so you cannot change the value of that. However, in the potentiometer, we can change the resistance, so it's variable. And then the next element is a capacitor, and this is a passive 2-terminal electrical component. Once again, this is how it's gonna look. Your right side, and it has 2 ends, 1 and 2, and this helps to store energy in an electric field. So imagine that this capacitor it functions like a battery, and then the voltage across the capacitor cannot change instantaneously. And one way to understand this capacitor is just think about the battery of your cell phone. The battery of your cell phone never ends like in 1 second, right? It takes through the day, depending on how much you use it. The same happened with this capacitor. it is storing voltage, and then it's releasing that, it's getting discharged little by little. It doesn't happen like instantaneously. And then we can think that the battery of your cell phone is just a big capacitor, if you want to think about that and make a little bit more sense of what is a capacitor. How do we add capacitors? It's going to be the opposite as the resistor. So if you have two capacitors and those capacitors are small and you want something big, you add them, you place them in parallel, and that's what you are going to add. So if you have 500 and 500, you're going to get 1,000. While if you have two big capacitors and you want to make a smaller capacitor, then you will have to get them in series like this. So let's think about two batteries. You can have two batteries, a 9-volt battery, but you are not required just 9. Let's say you are required 18. How will you connect them? So the way to connect those batteries will be in parallel to add those batteries. We cannot add like one continuous to the other one. In that case, the voltage won't change. It won't help us to add those voltages. So the way to do it is in parallel. Another passive element that we're going to be discussing today is an inductor. And as I said, it's a passive element, and it does have two terminals. And an inductor will look more like this green over here. That's how the manufacturers are done. But what is inside of here is just nothing else but copper wire in this fashion. And still, we will have two main ends, 1 and 2 terminals. This stores energy also, but instead this energy that is stored is going to be in a magnetic field. The units to measure inductance is henries, and the symbol is an H. And once again, in the difference between the capacitors and in the inductor now is that even though both store energy, this inductor voltage can change instantaneously. However, current cannot. So the current now will be changed. We will change it with time and not instantaneously. The inductor will be behaving exactly as a resistor, meaning that if we have two inductors in series, they will just add one to each other, and if we have two inductors in parallel, then they will divide basically. So that's all about the inductors. And then let's talk about a little bit a diode. And this diode is a two-terminal electrical component again, so it will have 1 and 2 terminals. And it doesn't have any resistance, so the current will go through directly. And the most important portion of this diode is that the current just travels in one direction. So the current for this diode will travel just from the positive to the negative in this fashion, in this way. If the current comes in the other way, in the opposite direction, then this diode will block the current and nothing will happen. So this is important to keep in mind about the diode, because now we are going to be talking about the light emitting diode, that is also called as LED. And I think that you're familiar with this term because pretty much now you can see on the TVs in your house, you have light bulbs, LED in your cars. LED have been popular lately. So it's basically just a diode, as I explained before. So one of the electrical components is just the current travels from the positive to the negative. But the difference with the other diode that I was explaining before is that this produces light. So this diode, once it is conducting the current from positive to negative, the light is going to be produced, and we can see lighting up this LED. This is going to look like this, and of course it has two terminals. The longer terminal is the positive terminal, and the smallest one is the negative. So we will see that the current will flow from positive, coming through here, light up the diode, and then flow through the negative portion. And then the last portion for this introduction class will be the breadboard. And a breadboard is basically where we connect all these elements. They can be all these passive elements. And that's where we measure current and voltages. And this breadboard, these are very similar to what we have in lab. The main portion here is the power where we connect the positive and negatives polarities of a battery, let's say. And we can connect it then in these extremes here or in the other side also. And what it is important that if you energize this little dot here, it immediately will energize the whole row over here. We do have in the other one, the next to it is the ground, and you can energize this one with the negative part of a battery, and the same will happen. It will energize the whole row, and the same will happen in the other side. While in these middle portions, if you energize, let's say, this dot on here, it will energize the whole column up to here. This other portion here, this is the second portion, if you energize this one, it won't energize this other one. They are not connected, the first half with the other one. So if you want to energize completely these two, you will have to energize this dot on here and this other one. So it's basically the green lights that you can see there that I try to draw them for better understanding. It's just how you will energize them or how you just connect them. And I promise you, this is the last element that we will be discussing today. And this is a timer. And it will make sense why I'm going all through these elements in a little bit. So a timer is just a chip. It's a microcontroller that it was set up, and it has a basic function. So it basically gives you times to turn on and off elements. And we will be using this timer chip in a small little project today. This one will have 6 ends. Oh, I'm sorry, 8 ends. And basically we'll have the ground, trigger, the output, and how we control it, the voltage to energize the discharge button. But don't overthink about this one. It will make more sense in a little bit. So I have been just talking about this element and a project that we are going to be implementing today. Unfortunately, in previous semesters, we used to be able to all interact with each other and have a meeting, and you will get exposure to touch these elements and to actually see with your own eyes. However, due to the circumstances this semester, we will have to implement something different. And I was able to find this app online that is called Tinkercad. I don't know if some of you are familiar with that already. If not, I will go through the process, how to set up and how you can get into the app, and we'll be able to implement a little project and also have better understanding of the concepts. So this Tinkercad is an easy to use 3D CAD design tool. So it will allow us to draw the whole circuit, and we will be able to actually simulate the circuit. I have created a class for all of you, so you won't have to create a new account. Instead, I have created those accounts for you, And with some codes that I will give you, you will be able to just get into the class and perform the experiment. And on top of that, I will be able to see your projects and see if you need extra help, I can help you. So we will come back to this portion. But what are we going to be building? So it's a switching LED mini project, and we will be using most of the elements that we discussed today. These 9 volts, it means the 9 volts battery. We will be using the timer, the 555 timer. Of course, these squares or rectangular blocks are resistors. So we're going to be using a 33 kilo ohms resistance, a 220 ohms resistance, and another 220 ohms resistance. We will be using a capacitor, a 10 microfarad capacitor. And we also will be using 2 LEDs, one red and one green. And we will be able to implement this small circuit into a project and then see how these lights will blink. And the whole process here is that if we increase this resistance, then the current flowing through here will have more resistivity, therefore the LEDs will blink slowly. The more you add resistance on this one, the more the LEDs will be slower. And you will be able to implement that and be able to play a little bit with that. So let me go back to this portion here. And let me think. So now here's the Tinkercad app. Oh, I'm sorry, you are not seeing my screen. I should share now another one. So let me share now my Google Chrome. So over here, we will be creating our project. I will give you instructions how to join that in a bit, but this is basically Tinkercad. What we're gonna do is just, you can just Google it, Tinkercad, and Tinkercad join a class. That's how you're gonna do it. And then you click on join class. Oh, it's because I'm already logged in. I'm sorry about that. So probably I should share a different screen right here. Okay, now let's do it. So Tinkercad join a class. All right, so we will click on the first link. Oh. Okay, so once you got it, join the class, that's where you're gonna enter the code that I will send you through the chat, and I will also send you directly the link to my class, so you will be able to join directly. So right now, I just send the link. You can click directly on that, so you won't need the code. Let me know if somebody doesn't have access to the chat, because I saw that some people have joined the meeting as guests for some reason, so they won't have access to the chat. So let me know so I can send you by email, or I can just share my screen and you can just type it, the class number. And then once you are there, they will request you a nickname. And if you give me a couple seconds, I can populate those nicknames for you. so you will be able to have your own nickname. So now what we're gonna do before we start with everything, I'm gonna share you a different screen with this portion. And now you will be able to see your name, and right next to your name a nickname. This is the name that you are gonna enter after you click into the link. So please do that. If you don't want to do it right now, you can just write it down. Those accounts are gonna be listed for you there. Okay. So and if you see twice your same name, just get the first one or any of those. That will work. So now I guess that you all have the nicknames, and let me know if I am going too fast so I can slow it down a little bit. So now we can just all work together on the Tinkercad app. So now I will be joining my class, and these are the steps that you are gonna do. So you click in the link, join the class, okay, I'm signing it in this one too. So let me join the class now here, and that's, you are already in EPICS Electrical 1. You will type your nickname. So I will click that's me, and this is the thing. This is what you are gonna be seeing. This is your own account where you can work and create designs. The first step that we are gonna do is to click in where it says EPICS Electrical 9. And what are we gonna do is we are gonna change your nickname to your real name. So that's how you're gonna be, that's how I know who is working here. So let's say I'm gonna say Karen Reyes, PA. So I know that that's me. And then I will click on Save Changes. So once it is saved the changes, I will go back to the main website. I will refresh the page, and now you can see here Karen Reyes. So by now, I will give you a couple minutes so you can perform this task. So you all can put down your names. Okay, I see that some of you have already entered your names. That's good. And don't be afraid. You can unmute yourself if you have questions. You want to let me know anything. In the meantime, just don't hesitate to interrupt me and ask anything. This is the only way that I can actually interact with you. So feel free to do it. So now that you may create your account and you own your own account, we are going to hit circuits on here and then create a new circuit. And this Tinkercad, it's a very useful tool because it allows us to create different designs in real time, and it gives us gives us all these electrical components ready for us to just click and drag to the main workspace. So we do have resistors, LEDs, as we talked. We have capacitors, we have batteries, have breadboards, we had many other electrical components. So it's a pretty useful tool that it lets you create the design. So now, to create this design, I'm gonna see how I can share my screen in this fashion. So give me a couple seconds. I will share with you my screen, and in the side of that, I will be sharing also the project. So what I want to share now is in this fashion. Yeah, I want to share the whole screen. Got it. Okay, so I will put in the side the project that we're going to be working on, and in the other side, I will put it the Tinkercad app. Are you able to see it like this with no complications? It's good enough the size of all for you to work. Okay, I guess it is.
Yeah, we can see it.
Okay, thank you. I don't hear nobody complaining, so I will just go with that. Okay, so now we are going to be dragging all the elements that we need to complete our project. So first, of course, we need a breadboard because we need a place where to do all the connections. So it's right here. Then we need a battery, and we need a 9-volt battery, and right here is our battery. It's pretty big, right? Then we will need resistors. We need 1, 2, and 3 resistors. So we go a little bit up and we drag a resistor. So here is 1 resistor, but this resistance, it says 1 kilo ohms, and we need a 220 ohms resistance. So what we do is that it allows us to change the value on here. And while I change the value here, I want you to pay a little close attention to the colors on here, because those are going to change too as we discuss the color code. You see how they change? And then also they are telling us that it's this kilo ohms, and we are not using kilo ohms. We are just using simple ohms. And you saw how this last bar changed. So we do need 2 different resistors of this, and this is gonna this also allow us to do Control-C, Control-V, so it gives us 202. And then I can drag my third resistance, and this one I will give it a value of 330 kilo ohms. So I will change 330, and this is actually kilo ohms. So we are good with the resistance. So we do have the resistance. Now what else do we need? We need a capacitor. So we scroll a little bit down, and here is our capacitor. And our capacitor, the value that we're going to be using today is 10 microfarads. So it's 10 microfarads, so we will change to microfarads here. That's how it looks. It should look by now. What else do we need? We do need 2 LEDs, 1 red and 1 green. So we scroll. We saw LEDs before. Oh, right here. I just missed it. And we need a red, and I will drag another one and change it to green. It's pretty cool with that. Let us even choose the colors. And you will see something that you will see something later that I like it. I like it even more from this app. And then finally, what we need is the timer. So for that one, I will just search in the search bar 5555, and it will give me the timer. So now we're good to go. We do have all the elements that we need. So let me close this part so we can have a little bit more room on here. And then what I'm going to be doing, I'm going to start connecting all my elements as long as with the timer chip. So what I'm gonna be doing is I'm gonna grab my 555 timer and I will place it right here in the middle, connecting in the middle of this branch that is divided in the upper and the lower of the breadboard. Other thing that I will do is I will flip my battery using this button here that it allows me to flip the battery. So I can have it in this fashion. So I can connect it on here to the positive and to the negative. And then it says, this is negative, okay. So this is the negative of here. So we will energize that branch. And what I like is that we can actually change the colors of the wires. And this is very helpful when we're gonna be doing all of these connections and wires get one on top of another one, and we need to color code them so we know where we are connecting. So for the negative portion of the battery, I always like, and it's just like more basic, use black. So we know that that's our black portion. And then for the positive side, as you can see the color, and these wires can move all around. I can energize that one and I will color code red. So now we have energized our two portions. Of course, since this is just a software, I am starting from energizing the plus and minus. If you are doing this experiment with the real elements, the last thing that you want to do is obviously energizing, because then all the connections that you're gonna be doing, you're just gonna burn all your elements. So yeah, there's a few tips there. And then we're gonna start with this number 1. And it says number 1, it will meaning the ground value will go to, as the name says, to ground, meaning that it will go to this negative energized portion of the breadboard. So how do we know which is this ground? This number 1 meaning the first portion, and what I like from this also for the Tinkercad is that giving you the names. That's what I add the names also on the picture that you're seeing. So you will have number 1 here, and you will drag this one to the negative portion. And as I said, this is I'm gonna color code it black. So far we got 1. Now we move to number 2, that is called trigger, and it says 2 is trigger here. It's gonna go just to 1 dot. So you can grab this wire here and then energize, let's say, this one here. And we're gonna change the color to orange, for example. Now we are in this point, the number 2. What else is connected here? To the same one is connected the 6. 6 threshold is gonna come from the chip to the same point where 2 is connected. So it will come to here. We will find where it says threshold. So threshold, this charge is not here, threshold is here. So you will click on here and we'll drag again. Let's make this a little bit nice. And we will do that. And I will color code orange again. So we know that all of these are coming to this portion. Now, we will need to connect to the same node a capacitor. What is our capacitor? Is this blue one here. So we can just connect it here. In the same energize when the two orange wires are, and in the other end. The other end of the capacitor will go to ground. So the other end of the capacitor, we can grab it here, and we will grab this one to ground, like this. And I will change the color. I really like this changing color so the wires don't get all confused for you. Okay, but we have to connect something else. In this same node, meaning in this line 16, we will need to connect now a resistor, a 330 kilo ohms resistor. that it was this resistor. Yes, 330 resistor. So we will need to connect this resistor first. So first thing that I'm gonna do, I'm just gonna flip it. And now that I have in this fashion, I'm just gonna connect it here, like this. Now, let me, oops. I want to move this wire a little bit here so it doesn't confuse us too much. Okay. And then the ends of my resistance, my resistor, is actually connected. If you follow the line of the end of the resistor, is connected to number 3. That is called the output. So it's connected to another node. What we can do is that we can find here where is the output, that is number 3, so here, and then grab my wire all the way where the resistor is at, like this. And then we can change the colors to pink, for example. So now I am wiring this part. I am done up to here on 3. Okay, what else do we need to connect? We need to connect our LEDs. So now, let me move this over here. And then we need to connect our two LEDs. The first one is the red one and the green one. But you see, they are gonna be on the opposite. So in the same node where 3 is connected, we will be connecting our red, that this is the negative and this is the positive. Remember that the negative is the short end and the positive is the bigger end. So since this node is connected to the negative, we will connect like this, the negative and the positive. And now the other portion is the positive coming from there to the negative. So we will grab this one, and what we're gonna do is that we'll be connecting like this. And this is when it starts all getting messy a little bit. Now we know that this positive and this negative are connected between each other. How are we gonna be doing that? So this is the negative or my green. I'm gonna connect to the positive of the green. And I will change the color to something that we can remember. Let's do yellow. So now I have connected in this fashion. And in the end, where all of these are connected, now we can add our 2 resistors. So I'm gonna just flip this resistor in this fashion, like this, and I will connect it over here. Then I'm gonna use my another resistor, and for this one I will need to connect it on here also. However, I won't have enough space, so let me do it like this. However, I will have to pull another yellow to here. And in that fashion, this terminal here is this end on here, and the other terminal, this one, is my lower terminal to ground. So what we're gonna be doing, the first terminal will go, meaning this one will go to 9 volts from the battery, and we can color code it red. And this other one, the second end, will go to the black portion, to ground, calling it like that. Now, the only thing that we have missing is the power button 8 and 4. So the power is this one that is going to be connected to the power board, the battery, which is here, and we will color code again, so it's red. And the number 4 that is called the reset, which is this one, you can grab it here, it will be going to red again. So hopefully by now we are all completed with the connections. And the last thing that we have left is to click in Start Simulation and see how these LEDs blink. And hopefully they do. Hopefully I did a good connection. So let's click on that. And nope, the LEDs are not blinking. So of course I did something is not well connected on there. So let me figure it out. So now it will be like this. That is connected. And then we can run the simulations. And then, what you're going to be seeing so now, 33 kilo ohms, and if I start my simulation, this is where you're going to be seeing the LEDs blinking as fast as they are right now. So I will give you a couple minutes for you to figure it out, to do your connections also. And in the meantime, if you have questions, let me know, and I can help you solving them. I will leave sharing the whole picture if you want to do the connections by yourself. But if you want to see the actual connections that we were doing, let me know. So let me know how you're doing with the project. If you have any problems with that, let me know what you think regarding the progress, the app. I really think that this Tinkercad is very useful. It doesn't just let us do these simple projects with circuits. It also helps us to implement Arduinos. If you like that, it has different chips, so any project that you want to implement, it will be helpful, especially at these times that you cannot meet with your teammates. You can share projects and you can work together at the same time online. So it's pretty useful. And actually, if you want to code something, to add some code, it does have a window where it allows you to code. And yeah, it's very helpful. So hopefully you like it, and hopefully I was able to show you something new for you, and something that is it's useful also. So I will be checking right now how you are going in the projects. So I will go and see your classes. So let me first see David.
I have a question. Is pin 5 connected to ground, or is that just pin 1? Pin 5 is connected to nothing?
Oh, no. 5 is nothing. So 5
Okay.
you don't need to connect it.
Okay, thank you.
And then same applies for 7. 7 also is not connected to anybody, to nowhere.
Okay, and then when I'm counting like pin numbers on the schematic or whatever, am I starting at the white dot and like that's 1, and then
yeah, and then that's why I add these the names exactly. So number 4, if you don't find the exact number, you will see reset if you just place your mouse on top of those pins.
Oh.
So you will find. So if you.
I see. Thank you.
That's why I add them like reset, power, output, so it's easier for you to find.
Okay.
Thank you for asking. Okay, so I see that David, yours is working. That's great. Somebody wants to share their thoughts, something about the this app that we're using. I like your project, Brenda, and I see how you add the timer. So it's a pretty good one. So just let me know if you have more questions or anything that I can help you with. So I don't think that we do have more questions. So let's end up the presentation. Just let me click it on here. So I want to say thank you to all of you for attending today. As I said before, my name is Karen Reyes. You can contact me to this email address if you have more questions or you want to get the material to actually try it by yourself with the actual kit. I can help you providing you from lab that and it will be very useful for you too. Since all of you have been registered for this electrical series and you didn't have the exposure to work with the elements, I want to invite you. There is going to be another skill session with a presenter from Cypress Semiconductors. And we haven't established the date yet, but what is going to happen is that Cypress Semiconductor is shipping us some kits, electrical kits, and they will teach us how to use them. Those kits will be shared between all of you, so you will have to come one day before the actual skill session to the EPICS office and to pick it up, your kit, so you can implement this experiment at home. This is going to be super fun skill session. It haven't been scheduled yet with the time. We are working on that. So I want you to keep posted with those theories. And also, since I do have all of your information, I will be sending you an invitation. So if you want to learn a little bit more about these semiconductors, and this is a great way to learn and to get exposure to actually the actual kit that you will be implementing at home. So without anything else that I can tell you, thank you for joining me today with this skill session. Hopefully you were able to learn a little bit from this skill session. I also hope not to having bored you too much. And hopefully we have you in a different skill session, either for electrical or for Arduino. And yeah, thank you for coming again. And you have some questions, I will be here hanging out for a bit. If not, you are free to leave. And thank you once again.
Thank you.
Thank you.